Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 9th, 2025, just yesterday. The standout result is that the method lifts accuracy by exactly plus 18.6% on the MM-HELIX benchmark and adds plus 5.7% on general math and logic tasks. The paper is titled MM-HELIX, Boosting Multimodal Long-Chain Reflective Reasoning with Holistic Platform and Adaptive Hybrid Policy Optimization, and the implications for model training are quite significant. Beyond the gains, this paper introduces a new benchmark, a 100,000 trace data pipeline, and an adaptive hybrid policy optimization strategy that tames sparse rewards and catastrophic forgetting. So, Figure 1 shows the whole pipeline, which links evaluation, data generation, and training to cultivate reflective reasoning. Reflective reasoning means the model forms a hypothesis, tests consequences, and backtracks if contradictions appear. The left side sketches task domains and a benchmark that expose failures without reflection. The middle panels outline step-elicited data creation and an adaptive hybrid policy optimization trainer that mixes supervision with on-policy exploration. The right side illustrates reflective traces and downstream generalization. Alright, Figure 3 illustrates a single benchmark instance that tests reflective reasoning through the nibbles game. The left panel shows the grid with the snake and apples, and the model must plan a move sequence that avoids collisions. The question panel specifies rules and the required output format, which standardizes how answers are written. The bottom strip lists the solver hint and a reference answer plus the initial state, and the verifier simulates moves from that state to confirm correctness. Figure 4 shows how the step-elicited response generation pipeline turns rigid rule-based traces into natural verified reasoning. The key idea is guided refinement, which means a model writes better chains when it follows a scaffold of anchored steps and then gets checked by a verifier. The left workflow column depicts solver, scaffolding, model refinement, and verification. The top right block contains the rule-based chain. The pink block presents the enhanced reflective chain that reads more human and passes checks. Okay, since Figure 4 covered data refinement, Figure 5 shows how adaptive hybrid policy optimization trains the policy with a smart switch. Adaptive hybrid policy optimization is a single-stage learner that mixes on-policy exploration with off-policy expert guidance, activating supervision when rewards are sparse. On the top path, the policy generates responses and receives a group reward that feeds an on-policy loss. The lower path routes expert trajectories through a dynamic activation gauge, which outputs a coefficient that scales the off-policy loss. Both paths merge into one objective, so the model explores when it can and leans on experts when it must. So Table 1 summarizes performance on MM-HELIX and shows that reflective thinking helps but widespread struggle remains. The proprietary models block shows the strongest entry near 58%, which highlights how hard long-chain multimodal reasoning still is. A clear modality gap appears, meaning text-only inputs beat image and text, because visual state tracking tends to break. The open source block peaks around 33%, and the hours row records about 25%. Well, Table 2 compares training strategies and shows adaptive hybrid policy optimization on top. The method reaches about 25% on MM-HELIX, which signals a sizable lift over the base model. It also raises the average on general math and logic suites to about 42%, indicating transferable skills. On-policy means the model learns from its own fresh attempts, while off-policy supervision uses expert traces when rewards are sparse. Because the approach switches between these modes, it avoids forgetting and still explores effectively. So, two takeaways stand out. Reflective long-chain multimodal reasoning is learnable when models see stepwise traces, and adaptive hybrid policy optimization supplies the right mix of exploration and guidance to overcome sparse rewards and forgetting. The broader implication is a practical recipe for training and evaluating agents that plan, verify, and backtrack. Thanks for listening. I'm Alex, signing off from AI Research Roundup.